Thank you, Mike, and hello, everybody. It's such a pleasure to be here at our first EG. Really glad to be invited. I want to ask you, are there some of you here that enjoy reading about, learning about history? Yeah, I thought there would be. That was my passion, one of my passions when I was just growing up. I loved to read about kings and battles and empires and voyages of discovery. And then as I got older, I had more chance to learn about it in interesting ways. So when Millie and I were first married, we went on our honeymoon and lived in South America in a desert, living with Indians and smugglers and driving around in a roadless desert in a Land Rover. And I should ask, Millie, would you stand up so that people can see who you are? People might like to talk to her about either our honeymoon or about her work in mental health, which is really interesting. And then we lived other places. We lived in Libya, and we lived in Holland, and we lived in Italy, and we did field work in other interesting places like Tunisia and Corsica and Cyprus and Central Asia and places like that. And everywhere we'd go, we'd get fascinated with the people and the culture and the history, and we'd learn all the history that we possibly could. So we really had a chance to do that in many places. And then I found that there was a lot more history than just the history of human beings and kings and empires and things. I discovered as I became a geologist that geologists are the historians of the earth, and that's the way I think of myself, as a historian of the earth, because the history of the earth is written in rocks, because solids like rocks remember, whereas liquids and gases forget. And then later, when I got involved in the work that Mike mentioned about the impact of an asteroid or comet that killed off the dinosaurs, that meant I had to learn about cosmic history, because the comet and the asteroid are extraterrestrial, and I had to learn about life history because of the extinction of the dinosaurs. So all of those things were kind of coming together in my mind, all these different aspects of history, and I wanted to see how you could put them all together. So I was very susceptible when about 5 or 6 years ago I first heard about big history. And big history is not very familiar yet. I hope it will become so. But it is the attempt by scientists and scholars to understand how all of the past fits together, what we call the regimes of cosmos, earth, life, and humanity. Big history was invented about 1990 by the Anglo-Australian professor of Russian history, David Christian. And his wonderful book that's called Maps of Time is available over in the EG bookstore if you're interested in following up on that. So for the last 4 years, I've been teaching a course at Berkeley called Big History, Cosmos, Earth, Life, and Humanity. And I've been getting these absolutely wonderful students. It's been the most exciting, intellectually exciting and rewarding part of my whole career as a professor. I just love them. So what I want to do today with our few minutes together is first lead you back in time through history, and then we'll turn around and think about the meaning of what we've seen. So even human history impresses us with how much time there has been. In fact, my students find it, I think, a little bit sobering to think how many years have gone past, how many thousands of years back to the pharaohs of Egypt. It kind of makes you wonder, what's the significance of my brief life? You know, maybe if we're lucky, we'll live 100 years. What does that mean in terms of 5,000 years of Egyptian history? And then my students get another shock when they look back beyond the history of Rome and classical Greece, and they find out that there was a great civilization in the Eastern Mediterranean in the Bronze Age. Great palaces, cities, literature, and it all completely disappeared about the year 1200 BC. And it's sort of shocking to realize that a whole world, a whole civilization can disappear so completely that Homer, writing 400 years later, had heard some legends about the Bronze Age wars of Troy, and that's all. He didn't have anything written. And isn't it shocking to think that a whole civilization can just disappear? Well, then, if you go back beyond that to human prehistory, you find out about human ancestors like the wonderful fossil of Lucy, Australopithecus afarensis, or the new one that you might have heard about that was described last fall by Tim White at Berkeley, Ardipithecus ramidus from 4.4 million years ago. And it sort of makes you think deeply when you realize maybe that was my great, lots of greats, grandmother. And that takes you back in prehistory. And then you come to Earth history. And my students make a shocking discovery when they realize that although 1 million years is an awful lot of years, that just 1 million years is the basic small unit of time that geologists use when we think about the history of the Earth. And they learn that although human history goes back 5,000 years, written history, 5,000 years, Earth history goes back 5,000 million years. And we then talk about some of the interesting things that have happened in the history of the Earth. Some of them blindingly fast, some of them extremely slow. So among the blindingly fast ones was the extinction of the dinosaurs, which, again, Mike mentioned, and that our group at Berkeley that included my father and our colleague Frank Asaro and Helen Michael, in 1980 we published evidence that the extinction of the dinosaurs was caused by a huge impact of a comet or an asteroid. And 10 years after that, the crater was found in Mexico. And during that, immediately after that impact, there was so much dust and debris and smoke in the atmosphere that the surface of the Earth was pitch black and freezing cold, while nitric acid poured out of the sky onto the surface of the sea and the land. And after that catastrophic environmental disturbance was over, maybe half of the kinds of plants and animals that had been around were no longer there. And we mammals are the survivors who built the new world after that paleontological dark age. So that was a rapid one. There have been brief ones, or slow ones, excuse me. There have been slow episodes also. For example, 100 million years ago, Spain and Portugal were right next to Newfoundland as part of the supercontinent of Pangaea. And there has been a whole cyclical history of continents coming together to make supercontinents like Pangaea and Gondwanaland, and then breaking apart and dispersing to smaller continents like we have today. And there have been wonderful episodes. For example, at one point, if you think of Africa, suppose my hand is Africa and these fingers are pointing north, there was a time when Africa was the other way around. And modern North was pointing south. And other continents came together like South America and Australia and Antarctica to form Gondwanaland. How did North get to where it is? Did it turn up like that? No, it didn't. Actually, what happened was it drifted around under the South Pole and came up the other side, so that North is pointing right now. And as it crossed the South Pole, it left a whole track of glacial deposits from the South Polar glacials all the way across from one end of Africa to the other. Now, just can you imagine the confusion of the French geologists who, in the days before we understood plate tectonics and continental drift, discovered those Ordovician glacial deposits in the middle of the hyper-arid Sahara Desert? Those guys were really amazed. And I want to tell you one more thing about that, because Ordovician is one of those time names that geologists use to confuse normal people. And if you're interested in learning more about the Ordovician, you should talk to my friend Birger Schmitz. Birger, where are you? Would you stand up? There's Birger. He's made a fabulous discovery in a quarry in Sweden, about 100 fossil meteorites in these ancient rocks that fell in the Ordovician about 450 million years ago. and they represent a huge storm of impacts that must have just been plastering the earth, just bombarding the earth. I think it's one of the first great discovery of the 21st century in geology. You might like to talk to Birger about it. All right, so all those things going on in Earth history. Then if we look at the history of life, it's extremely complex, and it led to those wonderful animals and their amazing behavior that we saw in that wonderful movie last night. And it's so complicated that let's just focus on our human bodies. You know, we're all born with a human body with all its various parts, and they all function as a nice unit. But paleontologists can break that down, and they can find when different body parts appeared. So, for example, put your hand up to your jaw. Can you feel the mandible, the jawbone that moves up and down? Okay. And then maybe here just below your ear, you can feel the muscles. Move your jaw up and down, and you can feel the muscles that are making that work. And right in front of your ear, if you move your jaw, you can feel a little joint where your jawbone articulates with the skull. When did that come to be? The jaw is really important to us for eating and drinking and singing and talking to interesting people at EG. When did it come to be? Well, it first appeared in the Ordovician, 450 million years ago, something like that. And all of the animals that have jaws are part of the branch of the tree of life, the clade that's called the gnathostomata, which means the jaw mouths. And so we're part of that clade, and that means that every one of us is carrying with us a souvenir of the Ordovician. And we use that souvenir every time we chew or drink or sing or talk. All right, so that's life history, and maybe it makes you, again, it's a little bit overwhelming to think of all of those generations of ancestors that have passed to bring that together. Back beyond the history of life is the history of the cosmos, and it adds to what I'm trying to make this point to you that this history is overwhelming and sobering. And again, in cosmic history, we're struck not only by the time that's passed, but by the huge amounts of space there are, because the universe is overwhelmingly vast. I saw a wonderful computer animation of flying through our galaxy at hyperspeed with stars flashing by like snowflakes in the headlights. And then the simulation leaves our galaxy, and it flies through countless other galaxies in their turn, like snowflakes in the headlights. And so this very brief overview of all of history leaves us fascinated with all of the wonderful events that we've witnessed, but maybe kind of a little bit frightened or depressed by how much time and space there has been. So if we are manifestly not the center of everything, if we are just an infinitesimal speck that's lost in this overwhelming vastness of time and space, how do we make sense out of our human existence? I mean, how can each of us have any meaning at all? Well, one approach that intrigues me is to realize that in all of the regimes of history, all four of the regimes, you can recognize continuities where knowing what happened last year lets you kind of know what's going to happen next year, and then contingencies in which there's a sudden change, like the extinction of the dinosaurs, where everything is different afterwards. And each of us is the result of the most incredible set of improbable contingencies that you can imagine. And I'd like to take the rest of the time and just develop that thought with you. And where it's going to lead is to the notion that each one of us is so incredibly special that somehow it counteracts that feeling of being lost in deep time and deep space. Think about this. Imagine if you could write out on a huge sheet of paper your entire family tree. maybe back to the beginning of sexual reproduction. You've got 2 parents and 4 grandparents and 8 grandparents, another factor of 2 for every generation back. And that means that if you were to go back to the beginning of your family tree, this is the broadest meaning of family we have probably at EG today, you would have 2 to the 1 billionth power boxes. If you say 1 generation per year on average, that's a colossal number of boxes. And think of your family tree. Now, think about this. The sex of a child is determined more or less at random at conception. And if even one of your ancestors had turned out to be the other sex, they couldn't occupy that place in your family tree, and you wouldn't exist. Not you with your particular genetic makeup and your particular life experiences. Each one of us is colossally improbable. And in thinking about big history, we sort of met deep space and deep time. And now we're meeting something that I've started to call deep improbability. Let me give you a little story to illustrate that. So Millie and I have a friend named Maureen, a young woman that we're very fond of. And Maureen used to live in Boston. And one time, Maureen was flying out to San Francisco with her fiancé. Her fiancé was going on business. She was going to a wedding, and it turned out that her fiancé had enough frequent flyer miles to fly first class. But he didn't have enough for Maureen to fly first class. So he decided that he would fly first class, and Maureen would fly in economy class, right? So 2 or 3 times during the flight, the fiancé came back to see how Maureen was doing, but he sort of hesitated to interrupt because each time he came back, he could see that she was in this intense conversation with this young man who was sitting next to her. You see where it's going. By the time they got to San Francisco, the fiancé was history. And a few months later, Maureen married the young man sitting next to her, who happened to be one of my graduate students, all right? So this is a lovely story of just desserts, isn't it? But the point is about family, and it concerns their children who are extremely good in science and in music. And the point is that those children and their children, and their children's 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 children, on until the end of time, would never have existed if the fiancé hadn't decided to fly first class. Each one of us is just, well, I would say astronomically improbable, but astronomically doesn't do the job. Let me give you one more thought about this. So if you ask how many people will be born into the next generation of human beings, the answer is something like 1 billion, something like 10 to the 9th. If you ask how many possibilities are there, how many people might be born given the number of women's eggs that are available and the number of sperm that could fertilize them, if you do the calculation very roughly, it comes out to something like 10 to the 24th. Or 1 followed by 24 zeros. Okay, listen, what do those numbers mean? 1 billion and 10 to the 24th. If you take fine sand, 1 billion grains of sand is a double handful. That's the number of people who will be born. 10 to the 24th grains of sand fills the Grand Canyon. That's how many might be born. And we are the handful of sand that was born. Sometimes I find myself thinking about this enormous, endless cloud of souls out there who never got to be born, and we did. And when you realize that those odds are multiplied with every generation back for 1,000 million generations, you see that each one of us is how do you explain how improbable that is? Here's one way. You can say that the odds against your having been born dwarf the number of stars in our galaxy. It dwarfs the number of stars in all the galaxies. It dwarfs the number of atoms in all the stars, in all the galaxies, in the entire universe. We are, each of us, improbable beyond belief. Okay, what should we take home from that? What's the meaning of that? So one friend of mine, when I told him this story, he thought about it for a while, and he said, well, why are we always hating and killing each other? You know, every day should be a celebration, just relishing the fact that we are on this earth together. Well, not everybody will have that reaction. Another time I told this story, a crusty old Berkeley mathematician said, well, I can think of a few I wish hadn't made it. But nevertheless, thinking in this way has changed the way I think about people. And I realized that every person I met is a winner in the most pitiless game of chance that has ever been devised. Maybe you'll think about people that way. So at the end of a semester in my Berkeley class, my students have learned they've got an outline of all of history. They've learned to think historically. They have realized how much time and how much space there is. And we come to the last class, and we talk about how improbable each one of us is, and what that might mean for the way they choose to lead their lives. And quite a few of my students had tears in their eyes as we came to the end of the last hour. And I think that their reaction is an indication of the importance of understanding the big history, the history of everything that has led to the people we are and the world we live in.